Stop scrolling. Hold your breath. Because what I'm about to show you is not just another space video. This is a discovery that is forcing astronomers to rewrite what they thought they knew about the early universe. Just days ago, the James Webb Space Telescope captured something that NASA-affiliated scientists themselves are calling bizarre and unprecedented. A small, intensely red, glowing point of light, something that looks like a star. But the moment researchers broke down its light into a spectrum, what they found shattered every normal definition of what a star should be. Its name is MOM BH1. And if that name sounds strange, wait until you hear what this thing actually is. This object shows us a snapshot from just 660 million years after the Big Bang, a glimpse into one of the earliest chapters of cosmic history, when the universe itself was still taking shape. And from that distance, from that time, the light reaching us is so strange that MIT astronomers have given it a completely new category: a black hole star. Think about that for a second. Something that looks like a star from the outside, but hidden inside it is a massive black hole weighing roughly 100,000 times the mass of our sun. And this black hole isn't alone. It's wrapped inside an extraordinarily dense envelope of hydrogen gas, roughly the size of our entire solar system. A black hole disguising itself inside a cocoon of hydrogen gas, almost like something wrapping itself in a blanket to hide from view. And here's what makes this discovery so remarkable. When Webb's data was analyzed, scientists found what's called the strongest Balmer break ever measured at any redshift, the most powerful hydrogen absorption signal ever recorded at this kind of distance. That signal points to one thing: the gas surrounding this object is so dense that it's literally bending and distorting the light passing through it. The lead researcher, Rohan Naidu, a NASA Hubble Fellow at MIT's Kavli Institute for Astrophysics, put it this way: our picture of this object is evolving very rapidly. Think about that. This is a team looking at data from the most advanced telescope humanity has ever built. And their own understanding of what they're looking at is changing week by week. That's not ordinary. When scientists themselves say we're confused but fascinated, that's usually a sign that something big is unfolding. Now you might be thinking, is this just one strange, isolated object? Or is there something bigger hiding behind it? That's exactly where this story gets interesting, because this object is not alone. Back in 2022, when the James Webb Space Telescope sent back its first deep field images, astronomers spotted a set of small, strange, glowing red dots scattered across the earliest parts of the observable universe. They named them little red dots, or LRDs. These objects were so compact, so unusually bright, that no existing theory could fully explain them. Some scientists thought they were ancient, compact galaxies. Others thought they were supermassive black holes hidden behind thick clouds of dust. But every theory had holes in it, literally and figuratively. Now, with the discovery of MOM BH1, astronomers finally have strong evidence that might solve the entire mystery of these little red dots. And if that's true, it means the early universe could be filled with thousands, maybe millions, of these hidden objects that we've been dismissing as just weird red dots for years. And this isn't an isolated case either. A second discovery, called Glimpse 1775, spotted behind the Abell S10063 galaxy cluster, gave astronomers the deepest spectrum ever recorded of a little red dot, over 40 distinct spectral lines, most of which point right back to the same black hole star scenario. This isn't a fluke. This is a pattern. And a pattern means something that's happening repeatedly across the universe, something we simply hadn't been able to see until now. In this video, we're going to walk you through exactly what this object is, how scientists figured it out, why this hydrogen cocoon matters so much, and, most importantly, what this discovery tells us about the very origins of our universe. But before we go further, I want one thing from you. If this story fascinates you, if you want more real research-backed space updates like this, hit subscribe and stay until the end, because what you're about to hear in sections 3 and 4 might just change how you think about the cosmos. Now, let's go straight to where this all began, with Webb's deep, ancient gaze into the far reaches of the early universe. Let's rewind for a moment. How exactly did this discovery happen? MIT astronomers were running a survey known as MIRAGE, sometimes referred to as Mirage or Miracle in early reporting, aimed at finding some of the oldest, most distant galaxies in the universe, galaxies that formed almost immediately after the Big Bang. This survey used one of Webb's deepest observed fields, meaning researchers pointed the telescope at a small patch of sky and left it staring for an extremely long exposure time, gathering as much faint, ancient light as possible. And there, buried inside that deep field, researchers found a bright red point of light. At first glance, it didn't seem particularly unusual, just another red dot, possibly a distant galaxy. But when they examined its color profile, something felt off. The object was almost completely invisible in Webb's bluer filters, yet extremely bright in the redder ones, making it one of the reddest distant objects ever recorded. So why would something appear this red in space? There are two main reasons. First, redshift. The farther away an object is, the more the expansion of the universe stretches its light toward the red end of the spectrum. Second, dust and gas. A thick cloud of gas and dust absorbs blue light and lets red light pass through, similar to how a sunset looks red because its light travels through more of Earth's atmosphere. In the case of MOM BH1, both factors were at play. The object is so distant that its light took billions of years to reach us, getting significantly redshifted along the way. But redshift alone couldn't explain just how extreme this object's redness really was. When researchers performed spectroscopy, splitting the object's light into its component colors, the way a prism splits light into a rainbow, they found something that stopped them in their tracks. It's called a Balmer break. This is a scientific term describing a sudden, sharp drop at a specific point in an object's light spectrum caused by the behavior of electrons inside hydrogen atoms. Normal stars have Balmer breaks too, but the one in MOM BH1 was so extreme, so sharp, that it became the strongest Balmer break ever measured at any redshift. That means the hydrogen gas surrounding this object is so incredibly dense that it's absorbing an enormous amount of light passing through it. So the natural question becomes, if there's this much dense hydrogen around it, what exactly is this thing? A star? A galaxy? Something else entirely? Researchers tried fitting standard stellar models to the data, testing whether any known type of star, however unusual, could explain what they were seeing. Every time, the models failed. No known star could produce light this intensely red in this particular way. So they tried a different approach. What if, at the center of this object, there's a black hole pulling in surrounding gas, and that gas is so dense it completely conceals the black hole inside an envelope, making the whole thing look like a star from the outside? When they applied that model, a black hole of roughly 100,000 solar masses wrapped inside a dense hydrogen cocoon roughly the size of our solar system, the data suddenly fit almost perfectly. In simple terms, this isn't a star that happens to contain a black hole. This is a black hole that has gathered so much dense gas around itself that, from the outside, it looks like a star. That's exactly why scientists named it a black hole star. But it's worth emphasizing, researchers themselves are careful to point out that this is a model-based interpretation, not a direct photograph of a black hole sitting inside a star. It's the best fit explanation for Webb's data. And in science, no theory is ever truly final until new evidence arrives to test it. This discovery was published on August 12th in the journal Nature, and it immediately sent ripples through the astronomy community. Because if this interpretation holds up, it means we may have glimpsed a completely new pathway for how black holes form in the early universe, one that doesn't fit into our existing theories at all. So the question becomes, is this just a single, strange coincidence, or is it part of a much larger, hidden pattern spread across the early universe? The answer, as we'll see in the next section, might surprise you. This is where the story gets even more fascinating. As we mentioned earlier, back in 2022, when the James Webb Space Telescope began operating, astronomer Ivo Labbé of Swinburne University of Technology in Australia and his team spotted 13 small, bright red blobs scattered across the earliest parts of the observable universe. These objects would later become known as little red dots. At first, these tiny points didn't attract much attention. But as Webb captured more and more deep field images, these little red dots kept showing up again and again, and notably, they appeared to be surprisingly common during the first billion years of cosmic history. That fact alone was startling. If something is showing up this frequently in such an early, distant part of the universe, it likely points to some fundamental physical process, something that was happening repeatedly during that era. But the problem was, no existing theory could fully explain these little red dots. Some astronomers believed they were compact, ancient galaxies packed with stars. But if that were true, their brightness to mass ratio didn't add up. These galaxies appeared far too bright for their apparent size. Another theory suggested they were supermassive black holes, hidden behind thick clouds of gas and dust, similar to the active black holes we observe at the centers of galaxies today. But this theory had its own gaps too. The spectrum of little red dots, particularly their hydrogen emission line patterns, didn't match what we typically see from normal active black holes. According to a National Geographic report, one of the strangest parts of this mystery was that hydrogen signal, which is usually a sharp, clean marker, appeared blurred or broadened in these little red dots, meaning the hydrogen's light was spreading out rather than showing up as a clean, narrow line. This broadening is a clue that gas is moving extremely fast, and when scientists calculated the speed of this gas, the number was staggering. Roughly 1,080,000 kilometers per hour, about 671,000 miles per hour. Think about that. Gas moving at that kind of speed can really only be explained by one thing: an incredibly massive, gravitationally powerful object at its center. And when researchers estimated the mass of these objects, the numbers came out to somewhere between 100,000 and 10 million times the mass of our Sun, squarely in the range of supermassive black holes. This is where the discovery of MOM BH1 comes in and starts tying the whole picture together. For the first time, researchers had a dataset detailed and clear enough to confidently say, this is a black hole wrapped inside a dense envelope of hydrogen gas. And as scientists dug through more data, the story kept expanding. Glimpse 1775, an object detected behind the Abel S1063 galaxy cluster through a phenomenon called gravitational lensing, where a massive galaxy cluster bends and magnifies. The light from something behind it gave Webb its deepest ever spectrum of a little red dot. A team led by Vasily Kokorev at the University of Texas at Austin found more than 40 spectral lines in this data: hydrogen, oxygen, helium, and most of these lines didn't fit a simple rotating gas cloud model. Instead, the best fit model included something called electron scattering, the telltale sign of a dense, layered gas envelope, exactly like the one seen in MOM BH1. And then came the most jaw-dropping part: a June 2026 study where researchers scoured the entire JWST dataset, looking for how many other objects might fit this same black hole star pattern. The answer: 241 candidate sources. Think about that. Not just one strange object, but 241 potential candidates, all fitting this newly identified black hole star phenomenon. That number alone tells us this isn't some minor anomaly. This is an entirely new astrophysical phenomenon, a new pathway through which black holes formed and grew in the early universe, one that we've either overlooked or misunderstood until now. And if this holds true, we may need to rewrite a significant part of what we thought we understood about how supermassive black holes form. Because the biggest open question in astronomy has long been, how did the universe manage to build such enormous black holes so quickly when standard theories say it? Should have taken billions of years? The answer might be exactly this. Black holes, right from the start, gather so much dense gas around themselves that they wear a star-like disguise. And behind that disguise, they keep growing rapidly until they eventually emerge as the true, exposed, supermassive black holes we observe today. Now that we've seen what this discovery is and why it matters so much, let's move to the final section and talk about what this means for our future, our science, and our understanding of the universe itself. Section 4. The future and the real significance of this discovery. 1,000 words. So far, we've covered a strange red object, a hidden black hole, a dense hydrogen cocoon, and 241 possible cousins scattered throughout the early universe. But the real question is, why does any of this actually matter? First, this discovery tells us that the process by which black holes formed in the early universe might be very different from what we long assumed. Astronomers traditionally believed supermassive black holes formed gradually through smaller black holes merging together or through the collapse of massive stars. A slow, drawn-out process. But if we're already seeing black holes with roughly 100,000 solar masses within just 660 million years of the Big Bang, that slow process might not be the full story. Something faster, something we hadn't accounted for, must have been at work. Objects like MOM BH1 and Glimpse 1775 give us the missing link. A snapshot of a phase where a black hole is still hidden inside its cocoon, pulling in surrounding gas, growing rapidly but not yet fully exposed the way we see active galactic nuclei today. It's a bit like a creature that hasn't yet shed its cocoon. Until it does, we can't see its true form. And now, for the first time, the Webb telescope is giving us the ability to peer inside that cocoon. Second, this discovery reminds us that science is never truly final. Remember Rohan Naidu's words? Our picture of this object is evolving very rapidly. That's not just scientific modesty. It's the very spirit of science itself. Every new data point, every new observation, forces researchers to test and retest their theories. And when a machine as advanced as the James Webb Space Telescope is at work, we are literally seeing parts of the universe that no human being has ever witnessed before. Third, and perhaps most important, this discovery reminds us that the universe is still hiding some of its most fundamental secrets from us. We've mapped our own galaxy, discovered exoplanets, detected gravitational waves, and yet the moment we pointed our most powerful telescope toward the earliest reaches of the universe, we found things that don't appear in any textbook. And this is only the beginning. As mentioned earlier, researchers have already identified 241 candidate objects that fit this same pattern. In the coming months and years, as Webb continues its observations and as newer, even more powerful instruments, like upcoming ground-based, extremely large telescopes, come online, astronomers, we'll be able to map out the entire population of these black hole stars. That means, within the next few years, we might finally understand where supermassive black holes, the massive black holes sitting at the center of nearly every galaxy, including our own Milky Way, actually came from. This has been one of astronomy's most stubborn, decades-old open questions, and the answer might be hiding inside these strange red hydrogen-wrapped objects. So the next time you look up at the night sky, remember, the light reaching your eyes from those stars is billions of years old, and somewhere out there, hidden behind that light, strange objects like this one might exist. A black hole wrapped in a cocoon of hydrogen, sitting quietly, waiting for some telescope, somewhere, someday, to finally find it. That's the real beauty of science. Every answer brings 10 new questions along with it. And with every new observation, the James Webb Space Telescope reminds us that our journey to understand the universe has only just begun. If this discovery fascinated you as much as it fascinated us, drop a comment below. How many more black hole stars do you think Webb is going to find next? Don't forget to subscribe and hit the bell icon so you're among the first to know the next time one of the universe's secrets is uncovered. See you in the next video. Until then, keep looking up because there's still so much hidden up there waiting to be found.